All right, whenever you're good to go.
All right, let's see. So yeah, guys, everybody else in the group, I'm just gonna go with my questions, and if I'm not, don't want to hog it all up for yours, but it looks like we have lots of time, so I'll just get going. So the first one is, okay, so I've run all my models so far. Where I am, I've cleaned my data. I've done a first run of all my models, and I've done this to the very basic version. Is that basically so I'm on track for that?
Yeah, that is one of the main approaches that you can take for this project. Just run your data through every vanilla model.
Okay, and so the problem is I haven't done all the analysis, but it looks like all my models are totally overfitted. Like, some of the models do pretty okay on the trained data, but the test data is horrible. So how do I decide of which of those models to start focusing on?
Yeah, this is where you do have a little bit of flexibility. You can literally go by like which ones have the best of like whatever metric you're looking for with your test data, and then pick it like that. Or if you have like a model that you are leaning towards, like for example, like there are a couple that you can roll out. So let's say, just as an example, let's say you don't want to deal with like you don't want to deal with any scaling, you don't want to deal with any you don't want to deal with scaling or like multicollinearity, all of that stuff. You can immediately roll out like logistic regression, KNN, actually SVM. I keep forgetting to mention, and a student reminded me today that SVM is another model that you do have to do scaling with. So apologies for not remembering to say that. But yeah, you can just eliminate those three if that is not something you want to deal with, and then just take a look at the rest. Pretty much every other model, I think, is built off decision trees. So likely it'll be either, it'll be one of the ensemble methods that you can go into picking. So it's really up to you. If you already know that, let's say for your, in interviews, you would rather talk about one model over another, pick that model. Or you can really just go off which one has the highest scores.
Okay. Well, I scaled everything so far. That was part of my process. I scaled and rebalanced it all before running any of the models.
Nice. That
Even
works.
KNN or all that type of stuff. That's
Awesome.
okay. All right.
Yeah.
Hold on.
So you're saying, go ahead.
Sorry, just going real quick, just going off of the scaling. So like, I know some of the models you don't have to scale.
That's right.
Would it hurt it to scale it before doing it, or no?
It would not hurt it to scale it.
Okay.
So I guess, yeah, since we're on the topic of models, real quick, Henry, before your next question, I have put somewhere in this doc, oh wait, it's here. I'll also link it to the channel so it's more obvious, but I finally did this model summary sheet. So if you click onto here, you'll see that, oh, it's already open. But here I have a summary of all the models that we've talked about. The documentation is hyperlinked here.
Cool. Brief
how it works. You might use this in your presentations. Things to consider. And you can see that like for these first few, these are things to consider. There are a lot of things to consider, like scaling, dealing with multicollinearity, so on and so forth. And then for the rest of them, there are fewer things to consider because like all of these tree models, you don't have to deal with scaling. And again, I also have here, what are some attributes that you can use to get data, get information about your data through the model. So here you can see that a lot of them has like predict probabilities or feature importances, and also a couple things for ensemble methods, and also some of the important hyperparameters. So this might be a resource that for people who keep like getting confused between all the models, and I definitely was the same way. This is definitely a starting point. And just know I threw this together over the weekend, so it's not the most, I think it's a good like one-stop shop for like an overall summary, but there is definitely more information out there. So do your additional research on the models that you do want to use.
And so where's this link again?
So this is linked in the, I don't know why I decided to put it here, but I decided to put it within the workflow. Here you can see the model summary sheet. Yeah, I'll also, you know what, I'll link it on the top as well. Let me just do that. And it's no longer really a work in progress. Okay. And I want this to be the same font. There we go. Okay. All right. So yeah, those are questions about like picking your model, so that's good. Any other questions on that topic before maybe moving on to something else.
Well, just to sum up, you're saying just pick the one that you kind of want to work with, really. It's just because
Yeah.
I'm trying. One thing I'm gonna ask you as a function to like kind of make a spreadsheet, like or data frame like you had, where I did the test scores and F1 scores and all that type of stuff. So I'm having trouble with that function I'm doing, but I assume once I run that, maybe I'll find one that works better than the other. But still, just kind of you're saying choose one that you want to get to know better, really.
Yeah, that's right. I mean, a lot of like, doing like throwing your data into all of them and picking them based on scores is really with the assumption that you like that you don't have a preference for models, or if you don't have, or if you at this point still are not too sure which one would work better in whatever scenario, which is completely okay. So yeah, that's an approach you can definitely take. And with saving all the data into a table, the way I did it, I had my function output a dictionary such that, and actually I think I can show you all here. What did I call it? Here. So my function actually output a dictionary, and what I did was I ended up putting together a list of dictionaries. So you can see here, my function would give me something like this as the output. And then for each model, what I did was I ended up putting it together like this. It's not the cleanest way, but worked for me at the time.
Well, I'll show you my function later because I did a little bit differently. So I'm almost there. I just have a quick question about it.
Yeah, no worries, no worries. Yeah, all right. What other questions? Maybe, I don't know if anyone else has other questions before we go back to Henry, so we can like rotate a little bit.
Okay.
I had one question about that. Now I'm merging two datas. Now in that merge, I have in each of the data there are multiple columns which are same.
Okay.
So there are 3 columns which are same. So I want to. So is it possible only to merge with one column, or it's like I can select 3 columns and merge on each data?
You can do either. So it does depend on like, if you have 3 columns that match. So you're saying column ABC exists in both tables, right?
Correct.
Right. So if ABC for each row is the same, if you just choose to merge on one, it's fine. You can merge on 3 columns, it'll give you the same result, right? Because if ABC for each row on each of the separate tables, if they match, you can do that on all 3. Yeah, that's, I think in like pandas.merge, pd.merge, you can give it multiple. Let me just double check. Let's see, name series, maybe not this one. Let me just do a quick Google so that merge on multiple columns. Right. So you can see here you use pd.merge. Oh wait, this is right here. You have like the left on one column A, column B, right on these 2 columns as well.
Okay. Well, yesterday I tried this one. I just tried once and it threw error. So I mean, and since I did not have time to go over it again, I was confused like whether it is possible or do I need to use something else for joining in multiple columns.
Yeah, it should work, but if it's something finicky with your data, we can figure it out during one-on-one, or just send me your error.
Yeah, I'll do that. I mean, tonight most probably I'll be sitting. I'm not sure.
All good, all good. Let's see. Yes. Anybody else have any questions? If not, we can circle back to Henry. Going once.
All right.
We can circle back to Henry. I'm sure like, well, whenever he asks questions, it'll spark questions for me too, so.
Awesome. That's how it works. All right, go for Henry.
Okay, so for AdaBoost, you have to create a decision tree first and then run the AdaBoost based off that decision tree, correct?
Oh, that's a good question. So you don't actually have to instantiate it first. So in AdaBoost, the default is none, right?
Okay.
But it says if none, then it automatically does the decision tree classifier. So you actually don't have to worry about it at all.
Oh,
You can
I see. So it
actually
does it
just
for you.
instantiate. Yeah, you can actually just instantiate add a boost.
So, because I ran a default decision tree and then I plugged into add a boost, but basically it would have done that decision tree for me anyway, you're saying?
Oh yeah, it would work. It would work the same, just that the decision trees would have different hyperparameters. So if you just put the vanilla decision tree in, I believe it doesn't have a max depth of 1. It has a max depth of, I think, none, which just means that it'll just go to the maximum. So that works as well. I think I would say usually people who tune the models within their boosting models, that's usually something that you do with like a lot more time, but cool that you're checking it out as well. But yeah, I can imagine that model took a long time to run, or a relatively longer time to run. So because of the max depth equals none being the default, so if that's taking too long to run, you can just leave it as none.
Maybe it would take more with max. Yeah, well, I did the decision tree classifier first with maybe 5. So
Okay.
I ran enough that because I ran. So if I hadn't done that, it would have taken a lot longer because it would have had no max depth.
That's right.
Okay.
Yep.
And so what about gradient boosting? Is that kind of the same?
Yeah, exactly the same. So let me just go to the documentation here. Gradient boosting, it takes in the, let's see, where is, did I miss the estimator? Let's see, base estimator. What is this first star thing? And estimators. Huh. It is usually a tree because you can see these parameters are tree parameters as well. But yeah, you don't have to give it a already instantiated model, but you can.
Well, I don't think, where can you? Where is it? What's the
Yeah, that's
so
what I'm trying to look. Yeah, that's what I'm trying to look for as well. So estimators is something that you can pull out, which is correct. And this does, I have a feeling, am I missing one of the, I think that this is, yeah, it's definitely a tree. I just can't find right now where you would put a different,
or maybe you just run the tree
one.
within the parameters there. That's like your actual tree.
Yes, yeah. So these parameters would be your parameters for the trees.
Okay, so
sure.
maybe
So
for
like,
that one you don't instantiate a model first. You just
yeah, that's right. But usually you should have an option to use a different model. I just currently can't find it.
Okay.
But if anyone's interested, I'm sure a quick Google will give you the answer.
Yeah, it didn't, and I went over your lesson on gradient boosting, and I didn't understand like how it works. It's like start with a weak tree, then maximize the log likelihood by calculating the partial derivative of log probability for all. I don't know what's going on there. What's it doing?
Yeah, so gradient boosting basically is, it looks at your residuals and you're just retraining your model on the residuals. And so, for example, with your first,
y-hats, you mean by like your y-hats or your cost function, whatever?
Yes, the difference between your y-hat and your actual y. The thing is, in classification, calculating your residuals is a little bit different, right? Like, what's the residual of like classifying something as like A when it's actually C? So because of that, it uses log likelihood in kind of a similar way as logistic regression, because logistic regression is also a log likelihood model. So it's again just trying to fit. So basically, everything that's misclassified, your next tree will be trained on the misclassified data to try and correctly classify those.
Okay, and it uses log likelihood to classify things.
Yeah, in kind of a similar way as logistic regression.
Okay. And what about for the continuous variables that are in the data set?
Oh, for the continuous variables that are in the data set, it doesn't make a difference if the features are continuous or categorical. It works the same way. So like when you're trying to split, it works the same way. Yeah. Anything else? Let's close this out. If we want to take a break from questions from you all, these are some of the questions that came up here, and I did write some really brief answers here, but I feel like it is worth expanding on some of this. So a lot of your data sets have class imbalances. And so a question came up here was like, how large is your class imbalance before you need to do something about it, such as smoke? So answer is that there is no like proportion after which you have to do something about it. Again, because what affects your model's performance with class imbalance is not the actual imbalance, but much rather the separability of your data. So imagine, let's say you had a really, really severe class imbalance of like 99 to 1 instead of percentage. But you had all of your 99% like all on one side and your 1% class like really far away on the other side. So even though there's a very strong class imbalance here, because these like, imagine your blobs in space are so far apart, they'll be much easier to classify. I don't know if that makes sense. So it's not so much about like the exact number of your imbalance, but more on the lines of, how separable is your data. And a lot of models, the separability of your data is what determines how well it classifies. I would say if your models are predicting all like the majority class, so that means in your confusion matrices, if you see like numbers only on one side of your confusion matrix and zeros on the other side, then that's a pretty sure sign that you should do something about your class imbalance. If not, even if you have a class imbalance, but your models are still being able to make predictions on both sides, means that it's your data is more separable than not. That makes sense.
Whenever so you're saying basically like whenever it's splitting between the train test split, that's why the class imbalance kind of takes into effect? Or maybe I'm like not understanding properly.
Oh yeah, no, nothing to do with train test split at this point.
Okay.
What I'm saying is, let me just draw this with diagrams. I think that'll make things a little clearer. So let's say you have one class of data that's like all over here, and this is your majority class, right? So you have like a bunch of points all in this area. And imagine this is just some like n-dimensional feature space. And then your other class is all the way over here, and it's a minority class. The fact that they're so far apart, a lot of models will be able to detect this like separability. So for example, something like SVM, immediately they'll know, right, all right, that's where we'll put the hyperplane because it'll separate your data. Or if you have your decision tree, it'll be able to split on like whatever this dimension is. So even though there's a great class imbalance here, if my data is more separated in space, you might not need to do SMOTE. Compared to if your data set looks more like this, right? Or actually, to be even more dramatic, what if your data set looks like this? It's a little bit harder to separate. And even if you have like, a less severe imbalance, but your data is still like very overlapping, SMOTE may or may not even help. So there's a difference between like the separability of your data and SMOTE. And sorry, separability of your data and the class imbalance are like two different factors at play.
So what would we do in this situation here? Because that's exactly what is happening with like my models right now. Like SMOTE is not helping the imbalance. This
overlapping situation, yeah. So I don't remember if I talked to you guys about Tomek links at your last study group. Does that ring any bells? Okay, because I'm having like a bunch of study groups. I don't know, I forget if I mentioned this to y'all. Does Tomek links ring any bells for you all?
No.
Okay, good. So with Tomek links, imagine you have a data set that looks just like this. And let me actually make fewer so it's less dramatic. So let's say you have these 3 data points here. What Tomek links does, and it's actually called removing Tomek links, and I did actually link it in here. So this is something else that you can try for your data set. So what Tomek links does is it looks for your minority data points. So let's say these 3 ticks are the minority data points, right? with these minority data points, it looks for points from the majority class that are closest to these individual points. So actually, let me just undo this and make it into something that I can actually show. So same scenario, let's just say I have all of these majority data points here. And then I have minority data points here, here, and here. So what removing TOMEC links does, for each minority data point, it looks and sees which is the closest majority data point to it. So for this X over here, this star is the closest. This X over here, obviously this star is the closest, this one, this one. So it kind of pairs points up together. And then what it does is it removes the closest one. So you see with these pairs here, I'm actually going to remove this star, remove this star, and remove this star. And let me just put those X's back. So those X's are sort of like here and here. And that sort of helps to increase the separability of your data a little bit.
Okay,
so this is
good.
Yeah. So this is actually something that you can do over and over again, because if you have a very severe minority, a very severe class imbalance, is not going to balance it out. So actually, we really quickly look at this documentation here. They have a pretty good example here. So I'm not going to explain this too much, but basically this is the original class imbalance. They have 900 ones, 100 zeros. In fitting the TOMEC links, it won't balance it out perfectly. Like, because you imagine I'm only deleting 3 stars, right? So the imbalance is still there, but I'm trying to increase the separability of my data. So this might help. And what you could do is do this honestly a few times. And then when you feel like, and again, this is not something that is easy to tell. It's really more of just like trying it out. But what you can do is after you've done it once or twice, maybe even 3 times, you can then do smoke. And then your data will hopefully be a little more separable. Well, this is something that's not in the curriculum. I will say it's something that I just chanced upon like while surfing Medium articles, and I think it's pretty interesting. Again, with your data sets having a lot of columns, you might not see it help as much as well, but worth trying as well. All right, since we were talking about SMOTE, yeah, those are the additional pieces of information I have to talk about class imbalances. All right, what other questions do we have?
Well, I have that question about the scoring data frame. It's basically it's more of a pandas Python question.
No worries.
And but I'll show you. I'll share my screen and you can see what I'm doing.
Oh yeah, absolutely. Let's take a look.
Share screen. Okay, so what I'm doing is I have lots of different. I have every single model has its own file. I just found it simpler to do it that way. So for this one, so first I make a scoring data frame, a blank data frame of all this stuff. And then I save it to another file. And then here's my function. So I add scores to scoring where I read the data frame. Then I get all the information, and then I add it to the, I make a dictionary out of it.
Nice.
And then I add it to the data frame, and then I save it to back to the hard drive.
Very
and
cool.
Then here, this one I can load it all up and judge everything at the end.
Nice.
So that's how I decided to approach it. So here's my dummy classifier, and whenever I run it, okay, so now you see I've run it a few times and I get like several different ones, and I can't figure out how to drop all the duplicates. I tried this thing in the functions where drop duplicates, keep last in place equals true, and I'm not sure what's going on, why it's not working.
Ooh, okay. Let's see. You're dropping, and model scores is the data frame. The code looks right. The code does look right to me.
Okay.
maybe, ooh, off the top of my head, I can't think why that's happening. If you have your judge model score as the one with all the duplicates, that data frame that came up, if you do drop duplicates here, does it actually drop them?
Yeah, I'm not sure. I think I tried it and I was having weird. Wait, hold on. I'm gonna have to reload it, I guess.
All good, all good.
Okay, let's just try it now. So now I get nothing. Now I run, I get nothing. It's like it deletes everything. It's weird.
Huh.
That's what
Model scores equals to model score drop. And you just reran the top.
Maybe maybe because I have it in place, I shouldn't do model scores equals models. Maybe that's a problem.
Oh yes, yeah. That would be.
Okay.
Let's try that. Although, let's see.
Yeah, that worked. Okay, cool. I have to do it here.
Okay, so yeah, looks like whatever. Yeah, looks like that'll be what you do. I mean, one plus side, you'll also be able to keep all of. Oh yeah.
Did you save your function and then restart your kernel here? Because I think that might be the issue. You know, when you make a change in the function, if you save it and then restart the kernel, it might change that code, so you would be able to run it.
So maybe because I didn't restart the kernel, you're saying it didn't really, because I might have added this edit later on. So maybe that could be an issue.
So here, go to File and save it, and then rerun your kernel in the notebook you're trying to run.
Okay, let's try that.
That is definitely something.
No, save. Don't shut it down. Save the file. Go to File at the very top left.
Okay.
And then
I already saved it. Save all. And now shut it down. Right? Is that what you're saying, Ed?
Then go into the actual notebook you were in and restart that kernel.
Okay. Now it's just, there it goes. Well, I forgot this part. Yeah, it didn't work. Oh, whatever. I'll just do it here. That works that way, so that's fine. I won't bore everybody else with this little bug.
All good. Really, really awesome function, though. I'm really glad to see that some of you have been working on this. Yeah. Anything else from any of you? There are a couple other things that are questions that have come up that I think might be worthwhile talking about. All right, so if there's no other questions, let me reshare my screen and talk about confounding variables. So one thing, and I did actually post this in, I think not every channel here, but I think some of the dataset specific channels, we've been having discussion about confounding variables. And a confounding variable is basically a variable that is a result of your target variable. So that's something to keep in mind when you're doing your data cleaning. If you've decided on your target variable, very important to make sure that none of your predictor variables, like none of your x's, are something that are a result of your target variable. I don't know if that makes sense. So let's say if we're dealing with car crashes and your car crash data set, sorry, I think our alarm is going off, but we'll deal with that. Okay. So let's say we're dealing with car crashes and you're trying to predict the severity of a car crash. Predicting the severity of your car crash, let's say you have number of deaths with the car crash. If you have that as a variable, think about it as like, all right, if I'm trying to predict the severity of a car crash, does it make sense to use number of deaths as a variable? Because the number of deaths is a result of the severity of the car crash. So if you think about it in like a functional kind of way, if I want to make a prediction on the severity of a car crash and I want to use the number of deaths as a feature, will I be able to input the number of deaths to predict the severity of a car crash? So in those scenarios, I mean, that's like a very obvious one, but it is worthwhile to go through your columns and take a look and see which ones might be a result of your target. So that's what's known as a confounding variable, basically the order of like the cause and effect.
So in this case, like if we use, let's say, the vehicle. So we say which vehicle had the most severe car crash.
Mm-hmm.
Which one should we take as X and which one should we take as Y?
Oh, I would still use your severity as Y and then X to be your predictor variable. So maybe there's like a certain kind of car that, you know, is more prone to, or maybe like just in history, you've had like a certain kind of car model having more severe accidents. Then that can be one of your predictor features.
Okay.
And the kind of car that you have is not something affected by the severity of the accident. It could affect, the type of car might affect the severity of the accident.
Because when I was seeing the data, I saw that the larger number of deaths is like somewhat related to the size of the vehicle.
Ah, interesting.
So,
Do you say number of deaths?
yeah.
Interesting. That kind of makes sense too, because a bigger vehicle, you'll probably have more people
More people
sitting in it.
travel. So that,
Yeah.
that and then like when the because I've not seen the graphs and all, but I can just have an overview of it. But then I think if these two can be worked on, then it will actually give better results. I feel because it can
Absolutely.
have a linear relationship also.
Yeah, I mean, with most of the models that we've dealt with, you don't have to worry about linear relationships. You also don't have to deal with multicollinearity. So even though size of vehicle and number of people who died is correlated, you can use them both in most of the models that we talked about this mod.
Okay.
Awesome. Anything else?
Yeah, I have a quick question. We
Mm-hmm.
probably have gone through this before, but I just
No
need a
worries.
reminder. How does the model know what a true negative is or a true positive is? You know, like looking at your data, how would it understand that?
So your model technically doesn't know what the true negatives and true positives are. Really, it's just taking in like the labels of your Y. So it's taking in like, for example, your zeros and ones, and by default, 0 is negative, 1 is positive. And then just based on what it learns from your X data, it's able to come up with some output of like your predictions. And then in that case, you still really don't know what your true negatives, true negatives and true positives are until you put it into some sort of evaluation method. Like for example, putting it into your confusion matrix, which literally looks and see like, all right, which ones, if you have like, you know, imagine like a list of your actual Y values and the list of your predicted Y values, which ones match and which ones don't. And that's basically how it knows your true negatives, true positives.
Okay.
Your
Yes.
model, yeah. Your model doesn't actually know. It just, it has your true data to go off of, learns these patterns, and then tries to use the patterns that it's learned to create outputs. And then it's only through those evaluation metrics and methods that you can determine what are the true negatives or the false negatives, true positives, false positives.
All right, cool. Thank you.
You're welcome. Let's see. Anything else? There is one thing here that actually if any of you have time at like 2 p.m. Eastern, I actually also do, I'm going to be doing project office hours for my other cohort. So today I forgot, but I will post the link tomorrow. It's the same link every day. So if you all are free at 2 p.m. Eastern, feel free to join in the office hours for the other cohort, because I do talk about the same, I talk about the same thing, but because you have fewer office hours this week, that you can just use that as extra office hours. But anyways, questions came up about like, yes.
What about the merging of the students?
That is done in the Slack channels. So in the Slack channels, Kishore, I added you into the Slack channels. Those Slack channels that I've created for you for the different data sets have students from both cohorts. So
you'll be adding it today or tomorrow? Or you
I've already done it. I did it last week, actually.
Oh, okay.
So yeah, so Kishore, if you were to take a look into your car crashes channel that I added you to, that actually does have, I think, only one student from the other cohort is in that.
Oh, okay.
Yeah. But anyways, yes. I do think that because most students are just scrambling with their own projects right now, it'll be much more useful, I'm guessing on the break week when I'm not around, for you all to help each other out.
Okay.
Yeah. So yeah, one thing that came up as a question was, how do you see the relationships with between your target, which is binary or categorical, with all your with if you have like a bunch of other categorical variables. So one example that I gave, and actually let me draw it out for you, a really good EDA for this project is looking to see what the distribution of your variables are across the different classes. So if you have a continuous variable and you wanted to look at the distribution of the continuous variable across your zeros and ones, one way to do it is with histograms. I think histograms is a really good idea. Box plots is also another good idea, side-by-side box plots. So if I had, let's say, red is my 0 class, and I'm just randomly drawing, and green is my 1 class. So let's say this is just one feature. Red is just showing the distribution of that feature within the zeros. Green is showing the distribution of that feature within the ones. So with categorical variables, a little bit harder to do that. You can see I pasted that like random screenshot there, and I guess without context, it doesn't really make sense. If you have reds and greens, one thing you can do, let's say, and this is the same example, let's say you want to predict your severity of car crash, and let's say you just have severe, not severe. And let's have red be severe, green be not severe. And let's say one of your predictor variables is whether it's sunny or it's rainy. So here we can say just sun, and here is rain. All right, so what you can do is just look at the proportions. So within sun, let's say, oops, I wanted to do the squares there. So let's say within sun, you have this proportion severe with rain, this proportion severe. You also might want to normalize it so it makes a little bit more sense. And let's just go with blue to match that. And so let's just say for the sunny days, this is the proportion that's not severe. And for rain, this is the proportion that's not severe. And the two bars should be the same height. Basically, if you see a different distribution of your classes, it's likely to be a better predictor. And if you see something that looks like this diagram that I have screenshotted here, it's a perfect predictor. And let's say you have like a similar distribution within these bars, then it might not be as good of a predictor. So this, I think, would be a really helpful EDA graph if you have all categorical variables. All right.
So this can be right. We can test it with all the different columns with the same graphs, right?
That's right. Again, I would probably like loop it through. I would put your continuous columns and categorical columns separately so you can have the different graphs for both. Yeah. Let's see. All of this is just, I feel like you can read. I've posted a bunch of links to do that. I went through presentations last week. I've also linked an old study group video on PCA. If any of you are interested in potentially using PCA in your project, again, you would use PCA if you have a lot of columns and you want to whittle it down. You don't have to use it because I will go through it for real next mod, but that's there for anyone who wants to take a look. It's actually a pretty short videos. I think it's only like 22, 23 minutes long. Cool. Anything else? Awesome. Well, let's see. any questions that you have along the week, please send them to me. Again, we do start our break on Friday. So I would say no matter how little the question is, please send it to me. Might be even better to send it to those Slack channels with the other people in them, either our class channel or the data set channels, just so you know. A lot of the questions I've been getting have actually been similar for people working on the same data. So could be good to just post those questions in there if you have any. All right, if there are no other questions, going once, going twice. Unfortunately, I'm not going to see you all until Thursday. So I will post the Zoom link for the office hours for my other cohort. And if you can make it at 2 p.m. Eastern, you can do that. I have also at some point linked the playlist for that cohort. I'll do that as well, just because their office hours are like 4 days in a row. So it might be a little bit more like in line with what you're doing.
Okay.
Cool. Well, I will post those things right after this call as well. But if there's nothing else, I will see you all on Thursday or at your 101s.
Perfect.
All right. Bye, everybody.
Bye.